Okay, so the next set of notes here is going to be on graphing rational functions. So the first thing we need to know about a rational function is recall what a polynomial is, right? So a polynomial is usually in that form, y equals ax squared plus bx plus c. Basically, the only rule there is a cannot equal 0. Okay, you don't really have to know what that is for here, but when I define a rational function, I'm going to be using that word polynomial. So, a rational function has the form f of x equals px over qx. Okay, so qx cannot be 0. Why? Where is it? Qx is in the denominator. And remember this, where I said this is okay to have the 0 on top. But on bottom, no way, not okay, undefined, okay? We're skipping 5(1), so I'm just telling you that it's the inverse of that function, but we're going to skip that this year. The graph of a rational function when a is equal to 1 is shown below, so this down here. All right, so this is like the parent function, the normal one. Then we've got domain and range again. We always talk about domain and range in every single function that we've done, whether it was linear, quadratic, all those exponential ones and logs, okay? So domain, same thing. It's always your x values. In this case, it's all real numbers. So you can say negative infinity to infinity, or I'm going to use a sign that looks like this. That means all real numbers, okay? Because it's easier to, rather than saying like negative infinity to this asymptote, I just say all real numbers. And then the denominator can't be 0. So it's just the values of x that are going to cause the denominator to be 0. All right, here's that vocab word for you again. A line that a curve approaches, but it doesn't reach. So it's that line that it approaches. It's called an asymptote. We had this with exponential functions, and it was always that number that was added out to the side, but I always say, when in doubt, graph it out. And you can see there, okay? So in this case, you notice a vertical asymptote here, because it's approaching from both directions. It's approaching that vertical line, but it's never actually going to cross it. This one is your horizontal asymptote. Horizontal is y equals, vertical is x equals, because you have to think which axis does it cross, right? Horizontal line crosses the x-axis. Okay. So this, I just have the same thing at the top again. This is what a rational function will always look like. Hopefully it always has the 2. Okay, so how are we going to draw it? Now, I'm not taking your calculator, so just remember that you do have it if you want to use it. So because this kind of didn't copy well, it's x minus h plus k. All right, so step 1, draw your asymptotes. So that's your x equals your h value, your y equals your k value. So again, just like when we did exponential functions, this value here is your asymptote, your horizontal asymptote. Okay? To get the vertical, you're going to set this one equal to 0. So y equals h. No, x equals h, sorry. Okay. Points to the left or the right. Now, just get those from your table. You don't have to actually plug them in. So that's how we're going to get those points. And then just sketch in your graph. So the one thing that your calculator's not going to show you is the asymptotes. Other than that, everything else you can get from the calculator. All right, so let's just look at a couple here. It says, graph the function, state the domain and range of each. You have your calculator. I'm going to kind of just sketch it from what we have here, just because I think it's easier than plugging it in for you guys. This, remember, is your horizontal asymptote. So if I draw my axis, right, I've got y equals 1, or sorry, negative 1 is going to be a horizontal line there. Okay, to get the vertical asymptote, I have to set this equal to 0. So subtract 2. X equals negative 2, would be your vertical asymptote. So horizontal asymptote didn't really take any work. It was right there. Vertical asymptote, I have to do a little bit of work. Okay, so you would have seen those lines, or you won't see those lines, sorry. You will have to draw in those lines, and then when you graph it, you can kind of just sketch where each of the pieces go. Okay, so like this one looks like you have one here, and then the other one you have here. Now remember, those dotted lines I drew, those asymptotes, your graph cannot cross them, right? So just make sure you keep that in mind. All right, for the next one, what is in the asymptote spot? Nothing, right? So so the asymptote is y equals 0. So I'm going to draw my little graph here. There's an asymptote at y equals 0, so I kind of draw my horizontal line. Vertical asymptote is setting that equal to 0, so vertical asymptote is also 0. Okay, and then you go ahead and graph. When you graph from your calculator, you get 1 here and 1 down here. Okay, I'm going to go a little bit faster, so if you're starting to get lost, just pause the video or replay it. Oh, you know what I didn't do before I go any further? Let me do the domain and range. Okay, so back to the first one. Sorry. Domain, I said the easiest way of saying it is just say all real numbers, and then x cannot be whatever this value is, right? So x cannot be 2 because the denominator cannot, x cannot be negative 2 because the denominator cannot be 0. So to do domain, just say all real numbers, x cannot be negative 2. To do range, all real numbers, but y cannot equal negative 1. Why can't it equal negative 1? Because there's an asymptote there. All right, so then before I move on to the next one, let's do domain and range here. I'm going to say domain is all real numbers, but x cannot equal, well, where is your asymptote? What was your vertical asymptote? Oh, it was x equals 0. So x cannot be 0, right? Range, all real numbers, but y cannot equal, what is your asymptote? 0. Okay, so I definitely think it's easier to graph it first, figure out where those asymptotes are, then domain and range just come strictly from there. Okay, so moving on. This negative 5 here is your horizontal asymptote, so y equals negative 5. I'm going to change and do this so that it's black. And then I'm going to go down to negative 5. 1, 2, 3, 4, 5. Draw a horizontal line. Your vertical asymptote is whatever's in the denominator, right? Set equal to 0. So x cannot equal 0. So your vertical asymptote is at x equals 0. And then I just go on my calculator. I have 1 here. And I have 1 about here. Okay. Then when I go to do domain and range, domain is all real numbers, but x cannot equal 0 because that was where my asymptote was, right? Range, all real numbers, y cannot equal negative 5 because that's where my asymptote was. All right, let's look at the last one. Again, at any point, if you need to pause the video, please do so and try it again from there. All right, so this is your horizontal asymptote, so go to 2. Draw a horizontal line, right? Set this one equal to 0. Then you have x equals 3. That is your vertical asymptote. So 1, 2, 3. Then plug in your calculator, and you have one graph here, the other graph here. Domain, you're going to say all real numbers, x cannot equal. Range, you're going to say all real numbers, y cannot equal. So what can x not equal? Just go and look and see what your vertical asymptote was. Oh, it was 3. So x cannot equal 3. Your horizontal asymptote was y equals 2. So y cannot equal 2. So if you just start by writing all real numbers, then you can just quickly say cannot equal. Oh, sorry, that was definitely, did I just do that backwards? No, sorry, my other key had it wrong. Okay. What else do we need to note here? Oh, some functions are in this form instead, where you have y equals ax plus b over cx plus d. Okay, so that's just another form. Vertical asymptote is still, you're going to do you're still going to just set the denominator equal to 0. So since this stuff is in the denominator, it's just trying to give you a shortcut. You say you subtract d, which makes this a negative d, and then you would have to divide by c. So the quick way would be that. But I still would just always say, let's set the denominator equal to 0 to find the vertical asymptote. The horizontal asymptote is a little bit different here. We're gonna do a divided by c because it doesn't have that plus k value. All right, so let's look at the last group here, and then we'll be done. So for these, graph the function, state the domain and range again. Okay, so notice you're like, okay, there is no k value here, but this is a different type. So this one, horizontal, you need to look at your front numbers there. So since they're the same, I'm going to do 2x divided by x. The x's cancel. Your horizontal asymptote is y equals 2. Your vertical asymptote, you're going to set the denominator, which in this case is x minus 3, equal to 0. And then when you solve for x, you have to add 3 to both sides. So your vertical asymptote is at x equals 3. So if I want to state domain and range, domain is all real numbers. X cannot equal this number right here, 3. Range is all real numbers. Y cannot equal this number up here, 2. And then last but not least, we have to graph, right? When in doubt, use your calculator. But vertical asymptote at 3, so that means I go over 3, draw a vertical line. Y equals 2 is a horizontal asymptote, so I go up 2, draw a horizontal line. I sketch in my graphs, and this you can just get from your calculator, and you're done. All right, so let's look at the next one. Again, look at the form. It doesn't have that, 1 fraction plus k there, so this is going to be the one where you divide these. So horizontal asymptote, y equals x divided by x, which is 1. Vertical asymptote, in your denominator you had x plus 3. Set that equal to 0. Solve for x. Vertical asymptote at x equals negative 3. So then you're able to do your domain and your range. Domain, all real numbers. X cannot equal negative 3, because that's what we said our VA was, right? Range, all real numbers. Y cannot equal 1, because that's what our horizontal asymptote was. All right? Then we're going to go ahead and graph, just to practice graphing here. Negative 3 is left 3, vertical line. Y equals 1 is up 1, horizontal line. Sketch from the calculator. I think I had one up there, and the other one was like here. Okay, call it a day. All right, horizontal asymptote. Divide these two. So 2x over 4x. X is canceled. 2 divided by 4 is 1/2. All right, whoops. Vertical asymptote. Take the denominator. It's 4x minus 2. Solve for x, so you have to add 2 to both sides. So then I have 4x equals 2. Divide by 4. X equals 1/2. So, domain and range. Oops. Domain is your x value. Remember, range is your y. So all real numbers but x cannot equal. All real numbers but y cannot equal. In this case, even though I have the x and the y right above me, I don't have to worry about mixing it up because they're exactly the same. Okay. Then to graph. I'm going to go to the right 1/2. I'm going to go up 1/2. Draw my horizontal and vertical asymptotes. And then I'm going to sketch in my graphs. And they're just here and here. Okay? All right, moving on to the last one here. At any point, you can stop and pause, or if you want to try it and then watch the video to check it, you can do that. All right, so horizontal asymptote. I do y divided by negative 3x divided by negative x, right? So then those x's cancel. Negative 3 divided by negative 1 actually becomes a positive 3. So horizontal asymptote is at y equals 3. To get your vertical asymptote, remember you set your denominator equal to 0. So first I add 1, then you have negative x equals 1, divide by negative 1, x equals negative 1. Okay, once you have your x and your y, you can do domain or you can graph, doesn't matter. But domain is easy enough because it's all real numbers. X cannot equal, well, what is that x value? Negative 1. Range is all real numbers, and y cannot equal, well, what is that y value? 3. Right? And then you're ready to graph. So I'm just going to do black here to do my 2 lines. Erase this random thing. And go to the left 1. Draw a vertical line. Go up 3. 1, 2, 3. Draw a horizontal line. And then for my calculator, I have one here, and I have one down here. Something like that. Okay? All right, refer back to this whenever you need it, and do the 5-2 practice. Come to my Zoom office hours if you have any questions.